Hi there. This is a video for intermediate algebra. This is Unit 1, Section 3. And these are the notes for what we call literal equations. And what we're going to be doing is we're going to be solving for variables in a formula. All right, here are your standards. Here are your objectives. I'll let you read through that. But what I want to do is go ahead and take a look at some of these practice problems here of just doing the algebra, and then we'll look at some word problems. So let's take a look at this. Now, what this says is you have this equation here, and it's a formula. And it's v times y is equal to negative z times x times w. So what it wants us to do, it wants us to solve for x, all right? And I'm going to highlight that phrase. And then it says in terms of v, w, y, and z. And what that means is I basically want to get, my goal here is to get x equals something, okay? And that's going to have the variables v, w, y, and z. That's what it means when it says in terms of. So if I look, what I can do, and I can do this a bunch of different ways, but if I look at this statement here, I'm going to rewrite this. I've got v times y is equal to negative z times x times w. Now, one of the things that I can do here is highlight the fact that I'm solving for x. Now, if I'm multiplying a bunch of things, okay, by the thing that I'm solving for, what I can automatically do here is I can divide both sides by negative z times w, okay? And I could divide by negative z times w. And what happens is that your z's divide out, your w's divide out, and you're left with x is equal to v times y divided by negative z times w. And that's your answer, okay? What you have done is you've taken this equation and you've solved it for x, okay? By just isolating it on one side and moving all the letters to the other side, all right? And it's the same thing that I would do if I had numbers, but the reality is that, you know, these numbers, these values here are variables, and I'm still multiplying by x, and so I'm doing the opposite of multiplying by dividing, all right? Let's take a look at the next one. Now, this one says that we want to solve for f in terms of t. And so we've got this, this formula here, t is equal to 1 divided by f. Now, this one's kind of tricky, because what I know is that f is in our denominator. All right, and so what I want to do is move that to the other side. So the first thing I'm going to do is I'm going to multiply both sides of this equation by f. Okay, and what I can do here is that f divided by f divides out, and the next step down is that we've got f times t is equal to 1. Now, if I wanted to solve this equation for f, because that's what we're doing, I would divide both sides of this equation by t. My t's are going to divide out here, and then we've got that f is equal to 1 divided by t. And that's our answer for that. Let's take a look at the next one. Now, this one is your formula for perimeter, okay? And what we want to do is we want to solve for L in terms of P and W. So what I see is I've got this value here, L. Now, what's different about this one than the other ones is that I'm adding this 2W. So if I want to isolate L, what I would do is I would subtract 2W from both sides, okay? Now, on the left side of this equation, I'm going to have P minus 2W, and I can't combine those because these aren't like terms. And that's going to be equal to 2L. Now, if I want to isolate the L here, then I would divide both sides of this equation by 2, and I'm going to divide this whole entire thing by 2. And then my 2's are going to divide out, and I'll get that L is equal to P minus 2W all divided by 2, and that's my answer, okay? So let's take a look at the next one. All right, here, this one's tricky, okay? This one we have a fraction. And what we want to do, and this is your area of a triangle formula, and what I want to do is solve for B in terms of A and H. So what I can do, I could do this a bunch of different ways. I'm going to rewrite this. And instead of multiplying by a half, I'm going to write this as A is equal to base times height, B times H, all divided by 2. Okay? And once I have this, I can move my 2 over. And I can multiply both sides of that equation by 2. So my 2's divide out, I'm left with 2a on the left side and then b times h on the right. Now what I'm doing is I'm solving this equation for b. So I'm going to divide both sides of this equation by h. My h's divide out, and then I've got that b is equal to 2 times a all over h. And that's my answer. Okay, let's look at the last two. Okay, this one is a little tricky. All right, now this is the Pythagorean theorem. Okay, I have a friend, his name's Pythagoras. He's also your friend. Okay, and what I want to do is I'm going to solve this equation for a. Okay, so here's a. And so I'm going to move this b squared over to the other side. So I'm going to subtract b squared from both sides. All right, so that cancels out, that goes away. I'm left with a squared on the right side, and then I've got c squared minus b squared on the left side. From here, I want to isolate a, but I have a squared. So the opposite of having something squared is to apply the square root to both sides. Now what happens here is that if I take the square root of a squared, I'm just going to be left with a, and that's equal to the square root of c squared minus b squared. And that's our answer. We've isolated a. Okay. Over here on this one, I want to solve this equation for r in terms of a and pi. So what I notice here is that I've got r is squared, and it's being multiplied by pi. My first thing that I'm going to do is I'm going to divide both sides of this equation by pi. Pi's divide out, drop down my r squared, and that's equal to area over pi. Now, from here, because I'm solving for r, I want to apply the square root to both sides. And I then get that r is equal to the square root of a over pi. And that's our answer. Okay? So that's how we would go about solving these. Now what's weird is that, you know, on things like this, all you're doing is you're rearranging these equations and these formulas, and you're isolating one of the variables in that formula. Okay, so let's look at a couple of word problems and we'll go from there. All right, on this word problem, I'm reading it as Rob is an electrical engineer who works with lots of wires. He needs to calculate the length of the wire, L, in meters, using the electrical resistance R of the wires in ohms and resistivity, P, in ohm meters, and the area of the wire, A, in square centimeters. Now, as I read this, okay, that's a lot of information and a lot of things that I don't know what they are, okay? However, I am able to read this formula. R is equal to P times L, all divided by A. And we want to solve for the length of the wire. In this case, that's L. So what I'm going to do is I'm going to write out my formula. R is equal to P times L all over A. Now, the first thing I would do to solve this equation for L is I would get rid of this denominator here. I would move that A over to the other side. So I'm going to multiply both sides of this equation by A. And my A's divide out. And then I'm left with P times L is equal to A times R. And then I'm going to divide by P, and then we get that L is equal to A times R all over P. And that's it. That's what we're doing. So this is one where we are just rearranging this formula and solving that formula for L. For this next question, it says, in a half hour, Sarah is meeting her friends at the lake 6 miles from her house. At what average speed must she ride her bike to get there on time? So she's got a half hour. Okay, let's think about this. You're given a measure of time, okay? You're given a measure of distance, and it's asking you for speed, okay? So if I'm given a distance, a time, and a speed, I'm going to use my distance equals rate times time formula. So D is equal to R times T. All right, so what I want to do is we're solving this equation for speed. At what average speed must she ride her bike to get there on time? There's a couple different ways of doing this. But what I want to do is I want to solve this equation for r. R is my rate, which is my speed. Now, what I can do is I can divide both sides of this equation by t. So I end up getting that r is equal to d over t, okay? Now, what I can automatically do is I can substitute the values, like our distance. So in this case, distance is equal to 6 miles. And I know that our time is equal to half hour, which is 0.5 hours. Okay, and we're trying to figure out at what average speed must she ride her bike to get there on time. So I'm going to take those values and plug them in. So I'm going to take rate is equal to distance, which is 6 miles, divided by 0.5 hours. And when I do this, look at what you're given. You're given something in miles per hour, which is speed. Okay, so now I can evaluate that and do 6 divided by 0.5, and that's going to be 12 miles per hour. Okay, and that's the speed that we would need to travel. Okay, all right, let's take a look at the very, very last question. And for this, it says, a worker at a framing store is making a rectangular frame. He knows that the perimeter of the frame is 144 inches and the length is 40 inches. How can he determine the width of the frame? So let's write out our formula for perimeter. Perimeter is equal to 2 times your length plus 2 times your width. Now, what we're trying to figure out is determine the width of the frame. Now, we've done a similar one on the front page where we solve this equation for L. Because we're trying to figure out what the width is, let's solve this equation for W. So what I'm going to do is I'm going to subtract 2L from both sides, all right? So now, from here, I've got P minus 2 times the length is equal to 2 times the width. Now, I can divide both sides of this equation now by 2, and I end up getting that W is equal to P minus 2L all over 2. Now, here's the thing. We know that our perimeter, all right, the perimeter of the frame is 144 inches. We also know that the length is 40. So I can come in here and I can say that the perimeter is equal to 144, and I can also say that the length is equal to 40. Now, I can plug these values in and substitute them into our new formula for W and figure out what our width is. So from here, I'm going to write this out. I'm going to write 144 minus 2 times 40, all right, and then divide all of that by 2, and then that's going to give you W. So now from here, if I just want to evaluate this, first thing I'm going to do is I'm going to multiply 2 times 40. So I'm going to get 144 minus 80, and then divide that by 2, and that's going to be equal to the width. Now, if I take 144 minus 80, that's going to give me a value of 64 divided by 2, which is W. And then 64 divided by 2 ends up giving us 32. And that's our width. All right, and this is in inches. So we want to make sure we label that. So our width is equal to 32 inches. Okay, so that's how we would go about setting up and solving those. There's other ways of doing this, but I think what's important is that we write out our formula, we figure out what we're solving for, and then we plug in our values and evaluate and go from there. So I hope you enjoyed this video. Please let me know if you have any questions. We'll talk to you soon. Thanks a lot. Bye.